Example 8, the sum of the first 15 terms of an arithmetic sequence is 345. If A15 equals 65 and find A1 and D. So notice the things that they are giving us. The first 15 terms tells me n. So I know n is 15, and in this 345, that's the actual sum, right? The sum of, so they're finding S, or they're giving you S15 right here. S15 is 345. Of course, we know A15 is 65. And so we know a lot of stuff. We want to find A1 and D. So if you look back at the formulas, I think it makes a lot of sense to use the first one in that box. Sn equals n over 2 times A1 plus An. If you think about it, we only have one unknown in this formula, and that's going to be A1. That's one of the things that we have to find here. So Sn, in this case, S15 would be 345, and n is 15 in this example. That's A1. It looks kind of like a D, but that's an A. Plus An is A15. That's 65 right here. Okay, so keep in mind, n is 15 in this example, so we've got S15, n is 15, and A15 in this example. Bless you. So what? We just need to solve this equation. So this is basically algebra at this point. I can cancel this out. If I multiply by 2 on both sides to cancel out the 2. 690. All I'm doing is algebra here, so don't get confused. I'm going to go ahead and distribute this 15, I think. Or not. I'll just leave it. You could distribute if you wanted to. I think I'll just leave it. Next step, I'll just divide by that 15 anyway to cancel it. 690 divided by 15 happens to be 46. 46 equals A1 plus 65. Subtract the 65 over, and that's going to give me negative 19. A1 equals negative 19. So we've got A1, now we need to find D, and we can go back to the old formula. We don't need a sum formula, we just need a formula that has a D in it. AN equals A1 plus n minus 1 D. Notice this is not a sum, this is just talking about the nth term. This is the nth term formula. So I know the nth term. I know that 15th term was 65. So if n is 15, the 15th term is 65. A1 we just found was negative 19. N in this example is 15. If you want to do that in your head and go ahead and call 15 minus 1 14, be my guest, save yourself some time. So you're looking at 65 equals negative 19 plus 14D at this point. And it's just algebra. You're going to add the 19 over and get 84 equals 14D. And you're going to divide by the 14. D equals 6. Number 9, evaluate each sum. Okay, there's that sigma. That sigma notation, remember, means sum. But you've got the sum from I equal 5 to 12 of 5i minus 10. Now, one thing that you could do is just start plugging numbers in. Okay, you're plugging in 5. And if you plugged in 5, that'd be 5 times 5 is 25 minus 10 is 15. And then if you plugged in the next number 6, 5 times 6 is 30, minus 10 is 20. And then plug in 7, that's 35 minus 10 is 25, and so on and so on and so on. Okay, so you could find the individual terms and just find the sum a different way, okay? But we're going to use our formulas, all right? So one thing that we can tell here that you may not have noticed is what n equals. Okay, it's not obvious, but it's also not difficult to figure out. if you're going to plug in 5, 6, 7, 8, 9, 10, 11, 12, use your fingers if you have to, but that means we're going to end up plugging 8 things in, okay? It's not 12 minus 5 is 7, it's 12 minus 5 plus 1 is 8. There are going to be 8 terms in that sequence that we would have to add up. Okay, so n is equal to 8. And we can find a1 by plugging in the first number 5. Okay, if we plugged in 5, we got 15, that's a1. If we plugged in 12, that's going to give me the last term, the nth term. So I can find that you know, what would you call it, I guess, the last term, an, is what you're going to get if you plugged in 12. So think about it. Plug in 12. 5 times 12 is 60. Minus 10 is 50. I can see that that last term is 50. So I've got pretty much what I need in order to use that first formula. I've got the first term, I've got the last term, and I've got n equals 8. So we can find the sum. All right, the sum, or Sn, I guess, is going to equal n over 2 times a1 plus an. Well, n was 8, and that first term is 15, and that last term is 50. So we got 8 over 2 is 4 times 65. That's 130 times 2, that's 260. So the key in one of these problems is figuring out the different things that we know. We know the n value, we know the first term, we know the nth term. Once you find those things, list them out and use that to determine which formula you want to use. All right? I wanted to use that first one. Okay? So then let's look at the second one. So again, you know, what you could do is just start plugging junk in. If I plug in 5, that's going to be 8 minus 10 is negative 2. If I plug in 6, that's 8 minus 12, that's negative 4. I could go on and on. I could plug in the last term, plug in 10, that's going to be 8 minus 20, that's negative 12. If you really wanted to, you could plug all the numbers in and just take the numbers and add them up. Okay? That would be the lowest level of thinking that you could do. I don't know if you need to do that. I certainly wouldn't want to do that if I'm going from 5 to 100. But from 5 to 10, you're only going to have 6 numbers. Okay, remember 5, 6, 7, 8, 9, 10. 6 numbers. N equals 6. So it probably wouldn't be that difficult for some of you to just find all the numbers and just add them together. Okay? But anyway, I want to use a formula just in case those numbers got bigger. I know A1 is negative 2. I know an is negative 12, and I know n is 6. Looks like I can do the exact same thing I just did a minute ago. That sum is going to be n over 2 times the quantity a1 plus an. So we can go 6 over 2 times the quantity negative 2 plus negative 12, or 3 times negative 14 is negative 42. That's it. The sum of those terms, that sigma, is negative 42.